Welcome to the tutorial for bonded contact, and as per our last tutorial, I believe that most of you have meshed the geometry, and now let's move to the Aster Study module in this tutorial. Just start sharing my screen in a few seconds. So here we come here in the meshing module again, and you may be noticing that I have switched my position from left to right just because I realized that whenever I click somewhere here, then it's not visible to you guys. Let's get started with this. So up to this, we already did creation of faces, nodes, everything. The next part is to go to Aster Study module. So if you go this, if you click here at the drop down button, you'll see a lot of options. Just click Aster Study and a new component system will get open. Here it is. You will notice a current case and nothing else you can visualize here except current case. So now it's time to add a case. Right click here, just do add stage. Stage is nothing but a kind of case, like a load case you can define in terms of stage in Aster Study. Now once you do this, you will see that these options are activated: mesh, model definition, material, functions, boundary conditions, unload, pre-analysis, analysis, everything. There are more: post-processing, fracture and fatigue, and output. So now what we need to do is following the workflow of the Salome Meca. You can also check the first video where I just showed how to follow or how to do a simple static case analysis in Salome Meca. And we will do the similar case here. First we will read the mesh. These are all in sequence. See, mesh, model definition, material. You just need to follow the sequence. So we will just read the mesh. You check here, you will see two options: mesh 1, mesh 2. Let's select mesh 1, and then the elements will get visible here. So I am just keeping the name as they are. Okay, you have to read the mesh again. Click on stage 1, mesh, read a mesh. Let's select the mesh 2. So you see now it is available to view the mesh 2, and you will see that an automated name is created, mesh 0, for this. Mesh file format, you keep it MED, the MED format. So now you just follow the sequence. Stage 1, right click. Now what is next? It's model definition. Assign a finite element analysis element. So you will visualize here two options in the dialog box. One is substructure part and another one is finite element assignment. We will click here, assignment. Then in Salome, every menu has this kind of icons. You can add it from here. Now this drop down is activated because you added it, and this one comes. We need to select and assign proper element for this. Since our geometry is like all tet and it's a kind of solid element we want to assign, we will select everywhere, and here we will define mechanic. Mechanic is nothing but a mechanical system wherein you will find a different kind of elements such as beam, bar, 3D. For this one, we will select the 3D element as from the drop down menu. One thing we missed out here is assembling the mesh, but anyway, I'll just skip this step and just go back to mesh. Go to mesh and assemble it. Because I'll tell you why I need to do this, because when you come here it will say that you have two meshes available. So one is this, the frame, another one is this. What we need to do is to combine a mesh, keep them in a single mesh. So for that we need to assign it, assemble it. So go back to stage and then right click mesh. You will see assembly mileage. Mileage is a word for mesh in French. So mesh 1, mesh 0, and for the operation we choose this superimpose. The reason I prefer this option, or we need to choose superimpose, is in this we are going to define surface contacts for each solids, and they will be separately meshed and they will be kind of superimposed onto each other. That's how the contact will be modeled. In another type, you need to create similar kind of meshing on each, identical kind of profile on each elements. Say for panel also we need to create same kind of profile. It needs to be followed by the frame. So for now we just remember that we use a superimpose. Okay, so now you will see mesh 1 object is created, the assembly mesh. We can go back to model and we can assign to mesh 1. So you will see this assembly mileage mesh 1. Click OK. We'll again follow the steps. Material, we need to assign the material, but before that we need to define one. So let's click define a material. So let's use the unit system in Newton mm. So 210,000 megapascal would be the Young's modulus, and Poisson's ratio I am keeping 0.3. Since we are not going to use gravity in this analysis for now, I am not defining any weight density for the material, but in actual part, when in actual problem, whenever you have gravity playing a part, then you need to model the density as well. But you need to be careful while defining density here, because if you are following Newton mm systems, then the density must be in tons per mm cube. So the basic idea is the unit system that you follow, it has to be consistent. I'm just keeping I'm just clicking OK for now. So the material is created. Now let's assign the material. Go back to stage 1, material, assign a material. So since we have created the material and we have assembled a model, in this step we need to assign the material to the assembled mesh or model. Let's choose model. I prefer this way because whatever changes you make to your meshes, it can get forward into your model, and whenever you change the model or make some minor changes, it becomes easy to follow. So let's assign a material here, everywhere, and then this is the material that we define. Click OK. That's done. So functions and lists are whenever you have a dynamic load or a kind of tabular load acting on the system, but for now we are just going to apply a simple pressure on the top face of this panel. So I'm just clicking BC and load, that is boundary conditions. So we go to assign a mechanical load. So here you will see a lot of options here. For now we will select this, we can select either of these, enforced DOF or phase impo. And phase IMPO, it will assign the loads or the boundary conditions to the surfaces we select, and in enforced DOF it will be to the nodes elements. So let's see, you have options here. You can assign to group of nodes or group of elements. For point loads, it's like a kind of forces. It's not advised to apply on nodes as per code Aster documentation guidelines. It's always good to assign over the specified area, because your real life problem, there are no point loads. The load always acts on even smaller areas. That's an assumption that we make, that it's a point load. So let's assign this group of nodes. Here you will see that it's not visible, the fixed part, because the mesh selected is mesh 0, and that is mesh 0 is of panel. What mesh we are interested into is mesh of frame. So here we can select the nodes for the frame. And this way the surface is fixed. Now we also need to define another node or another load which is acting on the frame, not frame, the panel one, that is the pressure. In Salome it is defined as force and force face, that is the pressure acting on the face. So let's say it's 0.25 megapascal of pressure is acting, then we can directly mention this as a force face, and then select this element which is the load, the top surface of the panel, and we can assign it into negative z direction. So I'll just select the negative z direction, fz, let's say minus 0.5. So now two loads are defined already, but I hope you remember that we need to model the contact also. So I noticed one thing, that there were no contact elements for a frame when I open that dialog box. Let's see if it is there or not in the meshing model. And anyways, as per my last video, I told you that we also need to create the volume elements for one of the meshes. So why we need, I'll explain you in this video. So in the mechanical part, in the mechanical load itself, we need to define contact as a load, and it will be as if like one body is a master contact body and another one is a slave. It means they are attached at an interface, but whenever the master moves, the degree of freedoms of the slave will get moved based on that. Calculation will be based on the master nodes or the master elements. So we go to again BC and load, we will define assign mechanical load. Here you will see liaison options. So we go to liaison mile. Mile is a French word for mesh, and we go here. You see this group underscore ma underscore mate, that says that what is the master degree of freedom or master element. Now here they are all defined as 2D elements. The idea is to define them as a 3D element. And how we do it, that we need to do again by going to the geometry module and creating the volume elements. So I am choosing the volume elements as a frame, as a master element. So I will just close this. You will see it in red. Whichever detail is pending or it's not available will show in red. And from here I will again move back to the geometry module. So here we are in the geometry. We will show both frame and thing. And since this is a frame, I will create a group again. We will it as a frame. We need to select the frame, add, apply and close. So this way we created the geometry selection. Same we will create in meshing. So go to mesh, then this one is one for frame. So I can see contact 1 is defined here. So I don't know why it did not create. Okay, I am just seeing the first one, not referring to the mesh. Okay, now this one is for meshing. A group of node only for fixed FXD it has created. We can go and right click again, create group from geometry. Again, select contact frame, select here, apply and close. Done. You will see group of volumes as a frame and group of nodes as also the frame. We'll move back to Aster Study. The good part is here it has everything automatically passed over from the meshing, because since you have read the mesh here. So now if we go back to this step and let's go to liaison mile. In here you will see 3D element frame. So we can select it. Okay. And in here we need to select like what is the master contact and what is the slave contact. Let's say one is the master, then contact 1, and then this one is the slave, contact 11. Other things we keep it as it is. Major is this thing, massive, coke massive is a plate kind of contact, so we keep it as it is for now. So now it has created 3 types of load. Now we need to move to the next step, which is creating the analysis, statics, mechanical. Then again we need to define material field, and then we need to define 3 kind of loads. So first load, it will select as it is the first by default, and second we will select this one, and here is the third load. We keep on saving this file. Now we will go to the post processing, because Salome Meca doesn't calculate the stresses automatically. We need to tell the software by commands that this way we need the post processing data. I'll just name the file as Resilin. This one is for stress, You can refer to my first video why we selected or why we follow this method. I will say this cfelga if will know, which is element and nodes. This one is element and Gaussian points. And we also need to do the criteria because we need to ultimately view the von Mises stresses. So SIEQ, it's the equivalent stress in von Mises and SI. Everything else we keep it as it is. Go back here and save. Again, right click, and we will tell it that set it as an output result. Here we need to tell it like what kind of, where we need him to save the data. Let's do reslin.med. Okay, I see why this results, since the results have not been defined, it showed as an error. I just wanted to do it again. Let's see invalid output in results. So what result to be saved? That has not been told. Let's say that. So now it has been told to the software. Okay, save it. Now we'll move to the history view and bring the case in here to solve for. Click here and then click run. So depending upon your system capability, computer capability, and the kind of machine you have been using, it will solve in a few minutes or seconds. Then you will need to click here Reslin. This one you can post process in another tool called Paravis also, but right now I'm going to show you how we can post process it, or how we can visualize the stresses and deflection in the default post processing tool in Aster. Just click post processing. So here nice looking plus is created, and here we can see the magnitude of the displacement. Here we can see the force. We need to refine the mesh in order to get different results which are matching with our calculations, and there are a lot of parameters involved in this. So I will also try to cover why sometimes results they don't match and how to match them with the actual calculations. And I hope that you have enjoyed watching this tutorial, and I keep looking to develop more tutorials as like this for future videos. Thank you and have a nice day. Bye bye.